Bismillahirrahmanirrahim, students. I have one more question on this work energy power thing. This question is basically on the work energy only, and this is one of the most defamed questions. In fact, many students have asked about this question over the years. This is a question from November 10, variant 41. It's a question number 6. So basically this question involves a lot of algebra, especially in its last part. So let me first do its first three parts, and then we go into the last part. Now the question says that we have a smooth slide over here, and there is a particle of mass 0.2 kg, and this is released from anywhere from this surface, not from the point A, anywhere from this slide. It is just released. So we release that with this. Obviously the initial speed is going to be 0. Okay, so it says the velocity of the particle at B is VB, and when this slide is basically this AB is a part of the slide, and then this particle, after like getting off from this surface, it moves under gravity and hits the ground, and it hits the ground with the speed Vg over here. Okay, so we are given that this point A is 3 meters above the ground. This is H, capital H meters over here, and this is the small h. Okay, so just to start with, you can have this from the Google, and you should have read the statement thoroughly before you look at this video. Okay, now it says in the case when that P is released at A, so the particle P is released at A. So I'm just going to focus on the part this A. Okay, and this is like this. So this is the A. So here it's 0 meter per second, and this is 3 meters above the ground. Okay, and here is our B, and this just goes on like this, and here is the Vg. Okay, so it says when it is released from the point A, it is given that the kinetic energy of the P at B is 1.6 joules. So here the kinetic energy is going to be 1.6 joules. So obviously at this point A, I should mention that here the kinetic energy is going to be 0 joules. Okay, so we have to find the value of H. So this is the H over here. I'll use that basic formula that the like when it goes from A to B, there is obviously an increase in the kinetic energy, and you can see that there is a decrease in the potential energy, because this is decreasing like this height is 3 minus h over here right now. Okay, so it has decreased a level of 3 minus h while it moves from A to B. So the increase in kinetic energy, we know that is 1.6. okay, and since there is a decrease in the potential energy, so let me put a minus over here, minus mg. So that is, the mass was 2 into 10, sorry, 0.2 into 10, that is 2, and this is going to be 3 minus h. Okay, so when we solve this, so we get that h is 2.2 meters. Okay, so this h over here, that is 2.2 meters. Then it says find the kinetic energy of the particle immediately before it reaches the ground. So again, we know that here it is 3 meters above, and here it is like, you know, on the ground level. So and it was at rest over here, and obviously the kinetic energy should have increased a lot when it has reached from the point A to the point G. It is hitting the ground. Okay, so once again I'll be using the same rule over here. So the gain in kinetic energy, I'll simply say that I'm simply writing that the kinetic energy at G, this point G. Okay, so that is going to be minus the total loss in the potential energy, that is 2.2 into 10 into this is it has fallen down 3 meters. Okay, so this is going to be if I write this as 0 minus 3, so this, you see that this is going to be equal to 6 joules. Okay, so there is a loss of 6 joule in the potential energy, and hence that would be the increase in the kinetic energy. Since the kinetic energy over here is 0, so the kinetic energy at this has to be 6 joules. Okay, so please don't be confused with this, the the minus game over here. Simply see that the potential energy over here is 6 joule. So same is going to be the kinetic energy over here. Then it says find the ratio Vg ratio Vb. Now it says we have to find Vg ratio Vb. So if I write this as Vg over Vb, that would be easy for me to find. Okay, now this Vg over Vb, I'm just going to use the kinetic energies over here. I know that the kinetic energy at the point B, that is given as 1.6 joule, and I've just found the kinetic energy at the ground level. Okay, so if I, instead of this, I try to find the ratio between the kinetic energy at G over the kinetic energy at B, that would be easier for me to find this Vg over Vb. So this is 6 and this is 1.6. okay, now I'll be writing this kinetic energy at G as half into m into Vg square, and this is going to be half into m into Vb square. You see there's a lot of algebra over here. So this Vg square over Vb square is basically 6 over 1.6. So you use your calculator. You you can simply write it over here. I'll be writing this as 6 over 1.6. okay, and then I just take the square root of the answer. So that is 1.94. So this is the answer. I have taken the square root, so Vg ratio Vb is going to be 1.94. That is the ratio between the velocities at the ground and at the point B. I'm moving towards the second part. Now this is the mind-boggling kind of a part, which will involve your skills on algebra. If you're good at algebra, you will understand this question easily, inshallah. Okay, now it says in the second part that in the case P is released at the point X. So now instead of releasing this from the point A, now this is being released from the point X. So if I just draw the part it from X, okay, so this is like this. So here it is X, and there is the point B, and here is the ground level. Okay, so we know that we've already calculated that this is 2.2 meters, and this is capital H. Okay, and we know that now we have just found this because we can use this height that we found in the previous parts. Okay, so this just goes down and hits this. So here is the velocity of the G. So we are given that when we release this from the point X, so here the velocity is 0, so that means the kinetic energy is going to be 0 over here as well. Okay, so we're given that Vg ratio Vb is 2.55. Now this Vg ratio Vb Vg ratio Vb, that is 2.55. okay, and we have to find H correct to two significant figures. Okay, now there is a tip for you, or maybe a very useful tip in basically that whenever you get stuck somewhere, you have to see that what have you done in the previous parts. So here this Vg ratio Vb is given, and you see in the last part we had to find the Vg ratio Vb. So let's start from that. Basically, when you have to find this value of H, so you need to find out an equation using the concept of energies. You will make up a relationship and equation so that you can find this H. Okay, so right now we know that the potential energy at this level, that is going to be 2H. Okay, Zaira, when you do that mgh, so this is the potential energy right now, and the kinetic energy over here is going to be 0 when it hits the ground over here. So here the potential energy will be 0 and the kinetic energy will be 2H. You should allow me to write that the kinetic energy over here has to be 2H, because the loss in potential energy should be equal to the gain in kinetic energy. Okay, so we know that the kinetic energy over here is 2H. So I'm coming to this point now. I'll convert this ratio of the velocities into the ratios of their kinetic energies. Okay, now let me write it as Vg over Vb, that is 2.55. Okay, when I square them, I have to square this as well, and you will allow me to write here the half m. Okay, so this is going to be half mvg square, and this is half mvb square. So this becomes the kinetic energy at G over kinetic energy at B, that is 2.55 square. Okay, so kinetic energy at G is this, and kinetic energy at over B, that is 2.55 square. So this was the kinetic energy at G basically. Okay, so I'm just going to move from this. So I'll be writing this as 2H, that is the kinetic energy at this G. So I'm writing this as, I'm changing this kinetic energy at G with the 2H, okay, over the kinetic energy at B. Guys, look at this. When it moves from X to B, so this is going to lose the obviously potential energy, and the kinetic energy is going to increase. So right now the kinetic energy is 0 over here, and if I calculate the potential energy over here, so that would be you can see that we have the height over here, which is 2.2. Okay, so the potential energy right now over here is 4.4 joules, and the potential energy over here, that is 2H. So I would say that the kinetic energy over here right now should be the decrease into this potential energy. So I will write it as, this should be written as, so this 2H over 2H minus 4.4. So you should allow me to say that the kinetic energy over here is going to be same as the difference in the potential energies at these two levels, that is going to be 2H minus 4.4, and I'll put that equal to 2.55 square. Okay, this is 2.55 square, and if you solve this equation, you will get this H to be 2.6 meters. Okay, this H had to be between this was 2.2. okay, so, and this is 3, so we can ourselves see that this answer seems to be correct to me. Okay guys, thank you very much. I hope you understood this. This was really a complicated question, and this was more like a question on algebra rather than a question on potential energy and kinetic energy. Thank you very much.